Thanks for joining today. My name's Amber. I'll be walking you through today's workshop. I've also included the sign up. So sign up for your Arize account so you can follow along. You'll also be prompted again. I'll just give everyone a few minutes to sign up for their account. You can either scan the QR code, go through this link, or just go to arize.com, follow the setup instructions so you'll get your account. Well, thanks everyone for joining. The workshop today is how to build trust in your models in production with ML observability and ML monitoring. So I'm Amber Roberts. I'm a machine learning engineer at Arize, and I'll be running this hands-on workshop today. So our agenda today is we're going to be talking about challenges with productionalizing ML models, talk about some of the key pillars in ML observability. Now, these are actually going to be done through the platform. So we'll be covering this information hands-on, and then the application of these principles, again, in the Arize platform. So definitely make sure you get signed up. So why are we all here today? Well, we're here to learn about like ML ops, and we're here because taking models from research to production is extremely difficult. So when you're experimenting in the beginning, when you're using a Jupyter notebook, when you're tracking your experiments, when it's kind of in that workflow and everything's controlled, your models perform quite well. It's easy to understand when something is wrong, but when you actually push that model into production, it's very difficult to understand why something is starting to fail, or even understanding if it's starting to fail, because these models fail silently over time. And in terms of being able to root cause, diagnose, and figure out what's wrong, we find that teams say it takes over a week to detect and fix a model issue in production. So about 84% of the teams that we've surveyed say it takes over a week. And that doesn't even include how long this problem might have been going on, and how many customers might have been affected by this. So if we could take, that week plus and shrink it down to maybe even a few hours from the time to find the alert and resolve the issue, that'd be huge for your customers, for your company, and for you just having confidence in your models in production. We also survey teams to understand where the time is spent in the ML pipeline. We know that data prep is a huge part of being able to train these models. So a majority of time is spent in the data preparation stage, followed by model training, model deployment, and then production. In fact, we see that teams say, less than 1% of time is actually spent on that production level workflow. And that really comes from the challenges that arise in that production setting. There's not a set routine for monitoring production, because there's not a set, set of issues that tends to be seen. Like each issue is very unique. You may not even encounter the same issue in production twice. So being able to look around problems that plague teams in model and data drift, and this applies to like all your models, all the features of your models, looking at performance degradation and data quality issues. And then there's some other issues that arise as well. So in a typical machine learning pipeline, you have a set of existing well-established tools for that data prep, model training, model deployment cycle. It's really that last mile folks get tripped up on. What a lot of teams have done is repurpose existing tools in order to try to mitigate these issues in production. And that can have some mixed reviews. A lot of times when you're trying to string together infrastructure, the time spent doing so and making sure everything's compatible is a huge lift for our teams. But also it's, if you're repurposing tools that are great for their intended purpose, they may not work as you would like them to for, their repurposed use. So that's really where ML observability comes in. It's that last mile, and it's kind of grouping what you're using from each one of those tools into one. And it's built explicitly for monitoring and production. So this is what you're going to use for all your post-production needs. Just to give you a definition of ML observability, it's a software that helps teams automatically monitor AI, understand how to fix it when it's broken, and ultimately improve data and models. And you might hear ML observability and ML monitoring used interchangeably. Just want to make the clear definition of ML monitoring, which is setting monitors up for performance, drift, data quality. Those are necessary, very useful, but they don't actually get to the why of the problem. Like they're more the tip of the iceberg. So understanding a few layers down from that is what ML observability does. Like it's going to help you root cause and resolve your model failure modes. So again, sign up if you haven't already. You can go to the Arize website if you'd like. There is that QR code from the beginning. You can also just type in the link. What's really nice about being able to sign up is this is a free account and it's yours. So we'll do follow along hands-on parts for the workshop, but you have access to this after the workshop. You can put your own data in, you could set your own monitors, and really be able to experiment with it after the workshop. So the use case we're going to be focusing on today is a fraud use case. So let's say that you're a machine learning engineer at a bank, you build a model to determine whether or not a customer's card transaction is fraudulent. So first you have to think what happens if you fail to monitor these fraudulent transactions successfully. What KPIs might suffer? Because if you're too conservative and you say almost everything is a fraud, you won't lose money in chargebacks, but you'll have very unhappy customers. Those customers are likely to churn. You can get an overwhelmed contact center, which is very costly, and just overall poor experience there. So you want to make sure that you're hitting those success metrics as close as possible. For our metric of success today, we're going to be using a false negative rate, which is also known as a miss rate. So it's the probability that a true positive will be missed by the test. So essentially, the higher the rate, the more fraud slipping through. So as opposed to accuracy, where 1 is like 100% accurate, that's the best you can get. False negative rate, if it's 1, like 100%, that means 100% of fraud is slipping through. So you want to get it as close to 0 as possible for being optimum. So we're going to start diving in. What we'll be covering are those key pillars of ML observability, show you how to automatically surface issues in data quality, model performance, model drift, and actually be able to do a cohort level analysis. So let's get started. Again, if you haven't already signed up for your Arize account, please do so now. When you first log into your Arize platform, you'll be greeted with this home screen, and it's going to show you a whole suite of models that have already been provided for you for exploratory purposes. Right now, my monitors are set. If yours aren't set yet, just go into an individual model. We're going to be using the fraud model, but the setup's the same. So you'll see the setup instructions. So go through the process, set up the model. We want you to make your default metric false negative rate, select your positive class. It's going to be fraud in the case of our model we're going through today. Turn on your monitors. And this is optional if you want to set alerts. Now I'm going to go back to the model I already have set up. So now we have our Arize demo fraud use case. So if you see, we already have some alerts set up. So we are going to go through performance, drift, data quality, explainability, and fairness and bias all in the workshop today. We're going to cover it briefly, but if you have more questions, we do have an Arize community Slack, and you can get any questions answered there as well. So definitely sign up and you can get your questions answered offline. So if I want to go into this fraud use case, I may first want to start with a performance. I'm getting an alert now that's saying my performance is degraded. So I'm going to click into that. I'm now brought into my monitors tab. I can see the monitor that has triggered, and I'm going to click into it. So if this is a false negative rate, it's triggering once it's about over 0.45. And being able to see when my monitor's actually triggered is huge. That's our first step for ML monitoring, being able to see when, but now we're going to dive into the why. So if I actually want to troubleshoot my monitor, I'm going to go here into troubleshoot model performance. Also, side note, you're able to edit these monitors however you like. They're automatically set for you in a completely automated, smart way. So we have smart monitoring using AI to detect and set your monitors, but these can be turned off and reset, and additional monitors can be added however you'd like. So let's go and troubleshoot this model performance directly. So now we're being taken to our performance tracing tab here. So if we go essentially to the home page, that would take us back to our original page. And then when we click into individual monitors, we're brought into different parts of the platform. So this is performance tracing, and performance tracing is actually a term coined by Arize. It's patent pending, and it's the breakdown of performance at the slice level. So I'm going to show you what I mean by that. First, what exactly are you seeing when we go into our performance tracing? You're seeing the data set. So we're using a production data set. These can also be changed out however you'd like. We have a set time window over the last month that can be changed as well. We're using a false negative rate metric and currently don't have any filters. So we are seeing the false negative rate over the month. We're seeing the performance metric, and then these, I guess I would call them these kind of shaded histograms here are the traffic or volume that's getting into the platform. So we always kind of, normalize by volume. So we're able to see those spikes as well. So then we have a performance breakdown at the feature level. So what this is going to show us is each individual feature that we've logged to the platform, these histograms where when I see something that is white or yellowish, that is our best performing segment. When I see something really dark or redder, that's going to be our worst performing segment. So these are our histograms, and then they're organized by what's called a performance impact score. So this is a slice or feature value impact on overall model performance. So we're essentially ranking the worst performing slices compared to our performance overall. So this is our global performance, and this is our performance at the slice level. How much worse is a slice or input performing compared to our overall performance? We also have feature importance being used as well. So feature importance are like SHAP values. They tell you how important each feature is to a prediction. And that is in here as well as a way to triage and start looking at the impact of features. So now that we kind of see the problems that are rising here, we're looking at things like merchant risk score, merchant ID, state, seeing the impact that these are having. If I wanted to click into, say, merchant ID, I can open this up, and now I see the volume, I see the individual impact scores, the false negative rates, or our performance metric, all included in this kind of bird's eye view. And what's really interesting is, we're seeing a false negative rate about, 0.4 pretty consistently. Like that tends to be our overall rate for this time range. So not great, not that bad either. Except when we get to this merchant ID of ScamEds, we see that this has a false negative rate of 0.9. So letting like 90% of fraud through, and a pretty high impact score. Volume, a decent amount of volume that can really heavily impact your performance. So if I want to, I can now choose to add this cohort as a filter or exclude it as a filter, or even view kind of the explainability level, which we will get to in a bit. So if I exclude this cohort as a filter, so if you see right now, overall, we're looking at almost a 0.41 false negative rate. If I exclude this cohort as a filter, we now went down to about a 0.39 false negative rate. You can add these filters by hand, but it's a bit easier to see them first and then just click and be able to filter on them directly. But you can add them here as well. And so just seeing about a 2% increase in performance just by adding a blinder to that feature. Now, we're not deleting anything. We're not taking any data out. This is to give data scientists a sense of if they were to start fixing that input, that, either that input or like that range for a numeric feature, this would pretty much add a 2% increase in performance. So I can choose to continue to add filters, but maybe I want to kind of take a different approach. And by that, I mean, I can add comparables as well. So again, I'm looking at data set A, this production window, and I can choose to either make a comparison to a different production window, see how this looks, or I can look at my training set. By looking at my training set, I'm able to compare what my model actually saw from the beginning to what I'm seeing now through my inferences. So now I have these comparables. And if I scroll down, now I'm going to see mirrored histograms, essentially. And what's really interesting here is if I go back to my merchant ID, if I open this up, now all of a sudden I'm seeing scam ads here. And what I'm seeing is no data from my data set B. So this is showing, again, data set A, traffic of data set A, performance of A, and this is B. So it's an A/B test of different environments. So essentially now being able to compare the two, I'm seeing that I have no data for this individual feature in my training. So at this point, I'd probably want to export this production data for the merchant scam ad so I can train my model on it and then properly be able to identify properly be able to create predictions for this input so that I no longer have a terrible performance on it. I can also click on any individual feature input. So if I click on merchant ID, I'm able to see the full details, but I can also click on view feature details and I'm brought into Drift. Now I can access this directly from my Drift tab, but sometimes I like to be able to see, am I experiencing feature drift? Is that really like an underlying cause for what's happening? So if I look at my PSI is a population stability index. It's a score like KL divergence, only it's a symmetric distribution. So it's a little bit more robust. It can be derived from KL divergence, but we see it's the most popular used way to measure drift in production because it works with both numeric and categorical features. And again, I mentioned it's pretty robust because it has a symmetric property. So whether you're testing the drift from distribution A to distribution B or B to A, it will give you the same result, but other metrics will not do that. So if I'm looking at drift over time, I'm looking at my PSI score, my traffic, my false negative rate. I'm able to look at these distributions as well. So I'm seeing a huge amount of drift. This type of drift is known as data drift. If I saw a drift in my actuals, that would be known as concept drift. And I am seeing a bit of a change in concept drift as well. So I'm seeing a few types of drift kind of emerging here. And again, I'm seeing that my current distribution or my production distribution versus my baseline distribution, which is my training distribution. When I compare the two, I see that I don't have any data for my baseline distribution, and it is causing a massive amount of drift. I can view underlying data quality as well. So if I click onto this, I can see some cardinality changes. I can see if there's a percent empty over time. So that's good to know, like I'm not getting a high amount of percent empties. The cardinality isn't all over the place. But I do see, one extra input here of cardinality that's not anywhere else. A change in cardinality normally means there's an input, it could be seen in production, not in your training. Some common monitors for this. So this is also going to be picked up on a data quality monitor. Some other examples for this would be, say you only trained your data set on capitalized states, and all of a sudden uncapitalized states are coming in. So you're going to want to set a monitor for if I get over 50, if I get 51, 52, 53, like that's concerning. I want to be alerted to that because that really shouldn't happen in the wild. All right, so let's just do a quick recap here. I can click on my overview. I see I'm in my space, and you can actually add folks to your free account as well. You can create different spaces for them, so a different organization, different space here. If you have specific security needs, just let us know. Or if you're interested in like an enterprise version, we can also chat with you about that. So what you saw me do is go into the Arize demo fraud use case, go into a performance monitor. If I didn't want to go into it this way, I could click into performance and begin troubleshooting directly. I would say most folks have, two modalities. It's kind of the first option is you're in direct troubleshooting mode. Like I get an alert, I want to know why I get an alert, and you go in that way. Or there's the exploratory phase where you can really just dive in, try to understand your data a bit more. Nothing necessarily has to be broken, but being able to do these A/B testing, you may be able, and we actually see people constantly being able to improve their performance by, just getting in that exploratory mode and really trying to understand their model a bit better. Another way that we're able to do this is through explainability. So if I go into explainability, for those that haven't really used it much, is a way to understand why your model is making certain predictions. Now, it has nothing to do with the actuals or the ground truths. That is based on your performance. So your performance will take into account whether or not a decision was correct. Explainability is going to tell you what features really led to that decision in the first place. So if I look at feature importances, I can see how much impact individual features are having on performance overall. So something like your merchant ID, your state's going to have a lot of impact, but something like grade, installment are going to have much less of an impact. And you can actually compare these versions as well. So let's get back into performance tracing. And I may want to look a little closely at California. I saw the state actually plays a pretty important role. And that feature importance level also appears here if you want to triage by that. And so it has a pretty high score. Maybe I want to see exactly how California is doing compared to other states. So if I add another comparison, I can choose to add like the state of California. Maybe I want to add it to both. Maybe I want to filter and compare California to New York. So I'm going to add this cohort as a filter. And I'm just going to make this for dataset A. And then maybe I add a filter just so I can show you how to do it both ways. Maybe I add a filter state that is equal to, let's do dataset B. Okay, very interesting. So if you remember, I said like false negative rate, we want as close to 0 as possible. We see that New York is performing much better than the state of California. And I can now compare these performances directly. So really able to see like where my models perform well, where it's performing poorly. What's kind of interesting here is that performance is pretty low in the middle range of FICO scores, but pretty decently performing at the end ranges. So that's one thing that you can walk away with. And also being able to continuously dive in to merchant IDs. I can also choose to start viewing more on explainability if I wanted to really understand these two different versions in the filters. I can go into explainability. I'm keeping that information that I just used. So essentially those filters. And I'm seeing the feature, California for A, New York for B, and the overall comparison. So what does this chart mean? So I have dataset A for like the feature importance, and this is a global feature importance. This is every prediction stacked on top of each other, average and taken the absolute magnitude. So merchant ID is the most important kind of influencer for those predictions, but you can see like how they compare overall as well. So if this is a global feature importance, this is where they stack up, and being able to compare those directly can really tell you information about your model decision. So as we mentioned before, like we didn't have ScamAds as a merchant ID, and we see that there's a huge impact on your prediction, whether or not something is fraud when given the merchant ID. So the fact that there's an entire merchant ID where, the training data wasn't there for it, it makes sense that that performance was so low and it was dragging down performance overall just by looking at this comparison. All right, and if you do have any questions, please put them in the Arize community chat. You can link to that directly from like the Arize site. We have a channel called Arize Platform Support too, as you go through the platform. And we want to make sure that you get your questions answered. So going to the overview page, we didn't really get to touch too much on this yet, but as you log data to the Arize platform, so you're going to log all your features, your inputs, your outputs, your metadata as well. So any additional metadata, you can put that in as a tag, and I'll show you how that looks. So again, we're looking at our performance over time, our traffic. We're looking at our false negative rate. And you saw me look at drift and being able to change out the baseline. You can reconfigure your baseline either in the config or kind of view your model config here, but you can change out your baseline at any time. Most of the time it's going to be a training set, but if you wanted to reconfigure this, you can do anything pre-production. So that's any validation, any training set, or you can use something in production. So if I wanted to use a window in production that corresponds to my training, I can as well. This is kind of what that looks like. And then you can use a moving time range as well. So if you have like seasonality components, you can make sure that fits in. Okay, great. You could also change out performance configs, evaluation time windows. And if you no longer want kind of smart monitor set, you can set them automatically if you'd like. This is also where you go to delete your model if you do want to end up deleting a model you have. All right, so additional parts for like the model health. So we looked at like the predictions. This is where you can get a quick drift and data quality check, as well as checks around your actuals and your individual features and your metadata. So your metadata will show up here with tags. You could also use performance tracing on tags as well and see how those kind of impact performance overall. Okay, so the next one I want to get into real quick is the drift tab. So we went into the drift of an individual feature, but I want to kind of expand that. So if I'm looking at prediction drift over time, I'm looking at a PSI score, I'm seeing when it starts to dip and when it gets pretty extreme. So if I'm looking at the traffic, I'm looking at the false negative rate, and what I'm doing is looking at this prediction drift over time. So as soon as my model starts to decay, I'll be able to see it. And again, I can change out this 24-hour kind of time range there. I can also do drift comparisons. And you might be asking, like, why do folks use drift? Well, if you don't have those ground truths back, or if you don't have those actuals, drift is going to be your best proxy to performance. So being able to use drift until you get those ground truths back, or maybe you have a use case like insurance, and there's a chance you may never get those actuals back. You want to be able to have a proxy to see when your models start to underperform. So here you can still look at our distribution comparisons, prediction value, either as a class or a score. Again, you can still filter down. And then we're ranking things now by prediction drift impact score. And we get this from multiplying our drift score, so our PSI, by our feature importance, which we use SHAP to calculate feature importances, but you can actually calculate SHAP however you would like and send those values to the Arize platform. We then get a prediction drift impact. So what are the most important features? And not only what are the most important features, but what are the most important features that are drifting a lot? Again, we see our merchant ID. If we click into that, we see the same view that we did when going through our performance tab and doing those checks. All right, perfect. All right, we seem to be following along well. So keep asking your questions in the Arize community Slack. You can also connect with me on LinkedIn, and I'm amber@arize.com if you have any additional questions. So let's keep going into our dashboards. So if anyone's familiar with Grafana, our dashboards actually are quite similar. I created this one the other day, but I'll create a new one. So you can create them from a few different locations. This is just me going into the dashboard tab and creating a dashboard here. So I can create a blank one. So this one's fully customizable, brand new, fully configurable. And so you can do that. Or if you wanted to look, say, at a performance dashboard, I can do that as well. So I want to name this one performance 2. I can select the model. I could select the versions of the model. Hold on, what did I do? I'm using that. Oh yeah. So it's going to select, it's actually already going to pre-select the model that you're in. So you can go into whatever model you want to use. And it's going to pre-select that. You can select the versions and you can select any features you want as well. So if I can select all the features and I can select my positive class, which I'm going to make fraud in this case. I'm going to create the dashboard. And like I mentioned, this is fully configurable. So if I want to edit it, I can move these, I can change these, I can edit the actual metric. If I want, change out evaluation types, add additional filters, and I can add and change any of these in a time series distribution or statistic plot. If I want to maybe add additional time series plots, it would come down to the very bottom, and I can change it and add it as I would like. So I can continue to make these very specific to what I want, and I can actually export these dashboards as well. But if I want to select this model, I think we were looking at how interesting, individual states compared. So if I wanted to filter on, again, California, I can now see how my accuracy changes. I can look at the prediction ones, and these are going to be different time ranges that you select. So I could select the last 6 months, 30 days, last week, however I'd like, and I can continue to add and stack these plots as well. Once I create these dashboards, they're going to be available not just in my dashboards here, but if I go to my homepage, you now see I have these dashboards. So depending on how you want to set your space, your workflow, you'll see who has access to what. But these are interactive. So if you're working in a collaborative space, your dashboards are going to be interactive. So the last one I want to show is on fairness and bias. So looking at fairness and bias is really important in understanding how your models are actually doing. So if I go into, I can actually go into any of these and see how my model is actually doing. So if I wanted to maybe understand fairness and bias of lending decisions, I can go, sorry, my mouse is almost dead. So hopefully I can get through the rest without my mouse dying. But I just go into my explainability tab. I can check to see what is influencing those predictions. And then I can go in my fairness tab and actually select attributes to see whether or not my model is being fair. So you'll see this score or metric of recall parity, essentially different parity measurements, because if you want to compare essentially an attribute, different groups, different features. When you want to compare the impact of those, you're going to use a parity score. So you want to see how close to 1 they can get. Let's just go through a brief example. So if I choose recall parity, I can select, I could select something like home ownership with a base being lease, the other one being mortgage. And these might not be the common ones that you're using for your recall parity, but being able to just understand how ones influence each other. For our example models, we don't have ones with what I call it, the protected classes or sensitive attributes, but a lot of models in performance are using ones with protected classes or sensitive attributes. and, especially ones in the healthcare system where they need those attributes in order to make correct decisions on diagnosis, on medical treatments. They're going to need that information. Some teams think, maybe if I just take out something like race or kind of, protected attributes around race, sex, even, I think there's about like 16 protected attributes that are like federally protected. So like sexual orientation, like if you have that information and you take it out, you might think, oh, I'm totally being safe, but you can use proxies as well. So like if you have zip code that's still making decisions, zip code can tell you a lot about like the age of the group, the race of the group, the sexual orientation of the group, like based on the location that they are in. So just being very careful, finding that bias early on and making sure your recall parity is very close to 1. So there's something known as the 4/5 rule. It's a practice of, if you're basically between 0.8 and 1.25, if that's where your parity lies, it's very close. It's pretty equal, and it's that equality aspect that tells us, is our model fair? If you go above 1.25 and below 0.8, it's an indication of model unfairness. And we could keep talking about this. There's a lot of interesting information that surrounds that. But just being able to rule out, particular features are being biased is really key to trusting your models. And, as more compliance comes up, using explainability and fairness and bias to make just decisions and be able to defend those is going to be key. So that is our overview page. And that is the brief overview of the Arize platform. So sometimes I just head back to this overview page. I can look at each type of individual monitor that has triggered. I can set my monitors as I would like. So I can create new monitors around Drift, data quality, performance. These can be sent to Slack, email, PagerDuty, the easiest way to reach you and your team. And we can go through them directly. So these are highly configurable. You can make them really incredibly specific to your needs. And if you don't want to do that, that's fine. We have a host of managed monitors that are our smart monitors that are automatically configured for you. Our teams have these very wide models, like thousands, hundreds of thousands of features. So being able to have them set automatically for every feature. So that's Drift data quality and model performance around every single feature that we automatically set. Arize is also built for high scale. So a lot of our teams that we work with, some might only be getting a small amount of predictions a month, and some can be getting, some could be ad tech teams where it's an incredible amount of predictions a day. You're dealing with terabytes. So working with these teams, being able to make sure that they're fully set up, supported, and can feel confident bringing their models from production, from research into production is a really key aspect for Arize. And so I covered a lot of the feature capabilities. We are also releasing, at the end of the month, we are releasing our unstructured capabilities as well. So you will be able to, because right now you can put in embeddings, but you don't have a way to visualize them in the space. So we will be having embedding capabilities and embedding drift, because your embeddings do drift in a high dimensional space. So being able to detect that as well is going to be really key for your model. So we have those capabilities rolling out as well. The last part is just being able to look at data ingestion. So being able to see if your data is getting into the Arize platform. There's probably a lot more questions you have more around the Arize kind of documentation. So we're just docs.arize.com. And here you will find a ton of information on different examples, common use cases, all our integrations. We also have additional integrations, like say your team has a very specific set, we can build integrations around that as well. Most teams, in terms about like sending data, like getting your data in, we have a few most common methods that we're doing that. So if I just go down to kind of like the data ingestion overview, our two most common methods are going to be using a cloud or like file importer. So we have a object storage integration, as well as a Python SDK, and use of APIs are still available. So I would say our Python SDK may be I would say it's probably our most used option. So just being able to open a Jupyter notebook, you have 20 lines of code. We have example notebooks for these as well. You send those in, you're all set. Our cloud storage option, you can find the individual keys for your Arize platform. Just go to space settings, and you can name your space and you can copy your API keys here. You can also add your members here as well. And if you want a whole quick start guide, you can click into our quick start. You'll see me pop up. And you'll be led through a series of tutorials. So you'll have these on hand at any time as well. So I want to make sure that we can use some of the time here to get your questions answered in the Arize community Slack. But that's going to be a lot of the key information. You can also organize projects, look at your monitors, especially if you set a monitor for, there could be thousands of these models, and, millions of monitors all set up. So being able to look at them all in one place, you can do that in your monitors tab on the side here. Look at all your dashboards, your team dashboards, and also your models as well. So that is a lot of the key information that people ask and when they want first round training on the Arize platform. And just to confirm, whenever you're doing these comparisons, so you can A/B test models. There are dashboards to A/B test different models. But I think most teams are really blown away by the capabilities of testing version control within the platform. So I can select, different versions on my production window. A lot of times these are challenger models. I compare them directly and then break down the performance by individual features. We also have a few additional capabilities around output segmentation. So confusion matrices, calibration charts, just as an extra workflow for you. And again, any of this data, you could export it directly and then use it for a retraining process, use it in your existing workflow, but being able to continue to filter, do version control, and really drill down into the root cause. So that's all I'm going to kind of present today. Thank you for everyone who is able to stay tuned, follow along, get signed up with the platform capabilities. I'd be happy to answer more of your questions offline, especially if you have a particular use case. What you're seeing is just a few example use cases. You're able to get your own data into the platform. There's also quick guides in our docs as well on how to get your own data in very step by step. And if you have any questions, again, happy to answer those offline. This was really great. I'm glad I got to walk you through the Arize platform, and hopefully you learned a lot about ML observability, how to not just monitor your models in production, but how to monitor them, have a troubleshooting workflow, perform a root cause analysis, and actually resolve those issues in production. Thank you, everyone. I hope you have a great day.